Hello friends, I am Shushant Raghavan. Welcome to Technical and Quality Session. For understanding the technical requirements and quality standards in clothing industry, making a sustainable garment, I have good practical experience in the apparel manufacturing sector. My skills are CAD pattern making, sample development, technical requirements, and measuring quality performance. Today's session is about how to make accurate operation bulletin in apparel industry. For more sessions like this, do like and subscribe to my channel. Now let's begin the presentation. Operation Bulletin. How to make accurate operation bulletin. Operation Bulletin. Being an industrial engineer, everyone trying to make an accurate operation bulletin. But often it is not even close to accuracy of 60%. In many cases, inaccurate operation bulletins were opened windows to unwanted discussion and arguments. Those arguments end up with further manipulation of OB to conservative zone for workflow person. Manipulation in operation bulletin is not integrated work. It is a crime. Inaccurate OB and its detail lead to inaccurate cost quoting and another end low efficiency. Subsequently, the delineation of the operation bulletin prepared may not solve. In this presentation, we review in detail about what are the parameters to be considered for 360-degree analysis to make accurate operation bulletin. Tech pack and style details. Tech pack is the primary details from the buyer or designer. Most of the costing SMV is prepared with a tech pack. Because at early stage garment samples might not be ready. Even if sample is available, I is responsible to review the tech pack thoroughly. Each and every comment on the sketch has to be read and understood well and verify based on that sample. If any deviation between the sample and tech pack, then IE will have to discuss with concern and get it verified. Product development comments. The product development comments are given in the style sheet or tech pack. Product development comments are the updates to develop samples accordingly. This part will assist IE for understand the garment construction clearly. Samples and product development comments are to be verified to prepare OB. Style specification details. It is containing the details of materials about body fabric, trim fabric, interlining, thread button labels, embroidery printing, applique, and other accessories required in product. Measurement chart. Measurement charts help to understand the size and length of the seams of the garment size-wise. IE could understand the size-wise changing parameters, small size to big size. There will be different in terms of measurement. Also, this will help to understand the seam frequency, seam distance, needle gauge, bobbin changing time, etc. There are two major types of measurement chart. Before wash, measurement chart need to set for actual production line. After wash, measurement chart need to set to achieve in wash garment measurement. Pattern and grading. The primary pattern is developed for base size. From this graded for another sizes. Usually the measurement is tracked with grading percentage. As per the below table, the order has a total of 5 sizes, that is extra small, small, medium, large and extra large. In that size M is the base size. From the base size, other size patterns and samples are graded. Note, measurement of size XS to medium is minus 7%. Measurement of size S to M is minus 5%. Measurement of size L to M is plus 6%. Measurement of size XL to M is plus 12%. Size-wise constant measurement, for example, cuff height, pocket size, front placket width, so on. We have to study it well to understand the right attachment. Special seams like pin tuck, smoking stitch, decorative stitch, pattern stitch, etc. are changeable size-wise. This should be checked and accommodated in OB. Buyer and QA comments. Apart from the above parameters, the QA technician and buyer give some comments on the sample. Most of the time there will be new addition or modification in the present sample. This should be considered in OB to set accuracy. Comments from sewing. Conducting critical review meetings is good practice. The IE who is preparing OB, they have to contact critical review meeting of product and order with floor level technician. They could share a good point to upgrade our OB to the actual setting level. Also, the bottleneck process will be reviewed well early in to make simple or easy methods. Fabric content. Fabric content is one of the key factors to estimate the SMV. SMV will vary based on fabric content even for the same process. For example, sleeve attaching SMV is not the same for woven fabric and knit fabric. Based on the fabric content, some additional process will be added. Few examples for a different kind of materials and SMV changing factors. Cotton, quite suitable in handling most of woven fabric made in cotton. Silk, very sensitive, some safety stitches and special machine setting required. Polyester, handling time is higher than cotton, cutting edge fraying is common, needs some safety stitch and special process for this fabric. Linen, similar to cotton, need to consider handling and fabric shrinkage or elongation. Fabric content. Chiffon, nylon, rayon, handling time is higher than cotton. Need some safety stitch and special process to achieve garment and seam strength. Spandex. Pressing temperature is restricted. Use lowest amount of steam and vacuum. Wool, handling time is higher. Need to increase machine duty. The sewing speed is less and additional handling required. Jute required special machine and handling. Leather required special machine and handling. Note, if a product made with above all different contents, the SMV will not be the same. Each and every fabric content has its own characteristic. Based on that, the making method and process will vary. The IE who making OB has to check with an expert about the details. Also suggested trial sewing to understand the realities of the fabric in process wise to make entire garment. Fabric count. Fabric count is highly contributing to fabric characteristics. Based on the fabric yarn count, the fabric characteristics will change. Fabric count measured by warp and weft counting in fabric. This also measured by GSM. Syntax of fabric count. Fabric count construction. Warp yarn ticket into weft yarn ticket. Warp yarn count into weft yarn count. Example count 20s into 30s, 120 into 80. Referring to the count of warp and weft, we could understand the fabric construction. Some loose or tight constructions lead to operation behavior changes. IE should be considered about the fabric construction. Could be referred sample swatch if the construction is not able to predetermine or understand. Based on the yarn count, SMV will vary. Fabric weaving. Fabric weaving type also contributing to fabric characteristics. Few major weaving types in woven. Plain weave, twill, satin, jacquard, dobby, crepe, velvet, chiffon, oxford, rib weave, etc. Few major knitting types. Jersey, rib knit, interlock, French terry, fleece knit, etc. Based on the fabric type, the operation SMV will vary. Required parameters have to consider during SMV calculation. Note, weaving itself there will be one-way, two-way, four-way engineered designs. The same has to be followed during the sewing process. This point should be evaluated carefully to accommodate in SMV. Fabric appearance and pattern. Garment durability is based on the fabric's direction, that is warp direction, weft direction, bias, etc. All the pattern mentioned the pattern direction. The pattern direction is considered to achieve a good appearance and quality of garments. But when making garments, some processes are not the same between each fabric to another. The detail should be considered while calculating SMV. Few examples for a different type of fabric appearance. Solid or plain fabric. Normal and no matching parameters. Stripe fabric, trimming, matching, mirroring fabric ways to be considered. Check fabric, trimming, matching, mirroring fabric ways to be considered. All over printing based on printing type. Engineered printing, matching, mirroring fabric ways to be considered. Embroidery fabric, matching, mirroring fabric ways to be considered. Buyers need to maintain grain line in the garment. Thread type. Garment seam quality is decided by sewing thread. Thread type is a key factor for operation progress. Thread count, content, construction, tenacity length, loop formation, linear strength, plies, resist to abstraction, flexible, twisted per inch, elongation, shrinkage, and strength is highly contributing to sewing performance. For example, 100% cotton thread breakage rate is high compared with spun thread. Polyester thread melting and breaking on heat. Filament thread breakage and handling time a bit high. Elastic thread inconsistency, seam formation, often setting adjustment required, thread breakage also quite high. Highly twisted thread untwist during sewing and break the thread. Inconsistent linear, seam defect and thread break, so on. IE should check and consider thread type to estimate SMV. Seam and stitch type. Based on seam and stitch type, SMV will vary. Let's take an example for side seam. Side seam process could be done with lock stitch, chain stitch, overlock or flat lock. But SMV will vary based on that. FPT, fabric pull test. Based on the fabric testing report, some of the processes have to be added or the seam has to be adjusted. This has to review by IE if any point to be considered in SMV calculation. GPT, garment pull test. Based on the garment pull test, some of the additional layers have to add or some special sealed stitch has to be considered. IE has to review and consider if any points to be considered. Pre-sewing process. Some of the styles containing pre-sewing process, for example, printing, embroidery, so on, IE has to consider while calculation SMV. Online special process. Some of the styles containing between sewing process, for example, applique printing, embroidery, so on. Product safety. Under the product safety parameter, some of the standard has to be followed in garment manufacturing. For example, button pull test, snap pinch, interlining bond strength, loop secure, sharp edge and metal safety, so on. Based on that, if any workmanship is added, then it should be considered in SMV. Order quantity. Order quantity is a considerable factor to fix the plant efficiency and plant output. For short quantity, we would not plan for a higher level of efficiency or output. Before completing of the learning curve, the order will be completed in production. Same way, huge quantity of orders could plan for higher efficiency and higher output because there will be production running after the completed learning curve. Color combo and color-wise quantity. A total number of colors and color-wise quantity also factor understanding adjusting time. At every end of the color, there will be a small change over in thread and a small adjustment in the machine if required. This factor also to be considered in OB and fixing the target. Size-wise breakup. Size-wise breakup quantity is key factor for individual operation performance. Some core replacement orders, size-wise quantity is not distributed evenly. There will be higher quantity or lesser quantity in some size. If we assumed a girl's dress with decorative smoking stitch, the stitch frequency is getting changed size-wise. So we have to consider the size-wise order breakup factor to update OB accordingly. Lineage and number of lines planned. Lineage is a key factor for calculating worker efficiency. Manpower calculation will be varied based on worker efficiency. If the line and operators are new, then we could not get 90% of efficiency. Based on lineage, worker efficiency and plant efficiency should be fixed. The total number of lines planned and line-wise planned quantity also a key factor for fixed plant output. Delivery date. The delivery date is a factor to cross-check planned output. What we are planning in OB, that will be followed in production. In some cases, the lead time will be short. In that case, we have to increase the manpower to meet the required rate. In some cases, shipment not achieved even after produced 80% of efficiency, which means the required output has not met. So IE has to read and understand both ways to achieve efficiency as well as the planned delivery date. Required rate of efficiency and output. The required rate of efficiency and required rate of outputs are not the same. Efficiency could be achieved even with available manpower, but the required rate of production to meet the delivery is not. So when we fix the plan output, the required rate should be considered. Another end, there should be clear understanding in production shop floor efficiency. This is an ancillary point to be considered in OB. Workshop efficiency or section efficiency. Section efficiency is the key factor to understand the skill set and achievable efficiency. For example, the sewing sections with 10 lines was achieving an average of 70% efficiency. Unless with proper cause, this section cannot plan lesser than that, which will lead to idle time. Another end couldn't plan 90% on average, which is very thought to reach 70% to 90%. The operation bulletin parameters should be planned for continual improvement of the section and factory. Machines. When we estimate SMV for a process, there will be option for different machines, but the type of machine and its application, SMV will be varied. For example, pattern sewer and manual machine attaching will not be the same SMV. Some of the machines facilitated with additional attachments, that is back puller, auto trimmer, edge trimmer, auto stacked, side slider, auto back take, so on. Based on the option using in the machine, the process SMV will have to be estimated. Plant efficiency. Plant efficiency is not a single factor. It has arrived from other factors of workers' efficiency, organization efficiency, learning curve type, lineage, line balancing, the skill set of employees, work content of the style, order quantity, so on. The logic of plant efficiency is organization, plant efficiency, worker efficiency. Plant efficiency should be in between the organization and worker efficiency. If we plant higher than worker efficiency, then it is of no logic. Workstation. Number of workstation calculation is not only based on OB. It is about the physical line size. For example, if the line has 40 workstation in the style required 20 workstations, in this case the line could be planned as line A and B with 2 output. Simply adjusting to 40 workstation will affect the line efficiency and workers utilization. In other case, if the style required 75 workstations, then can increase to 80 workstations along with planned output. 2 lines can be combined for 1 output. SMV. Process-wise SMV is to be double checked. Calculating accurate SMV for every individual process is enabled to get accurate SMV for the style. While we are using Pro SMV, we have to check correlation and deviation. After fixed deviation and make it accurate, then update SMV could be used in OB. Pitch diagram. A pitch diagram is a tool to understand the operation bulletin effectiveness. The actual pitch diagram is used in the production floor with the actual cycle time. Here we are taking SMV instead of actual cycle time to get the pitch diagram. The pitch diagram can be enabled in the OB sheet itself. Based on the pitch diagram, we could identify the bottleneck process. Followed by this, we could plan for line balancing. Key process for the learning curve. OB should be mentioned clearly about key processes where it is required training in advance, so that particular process can complete the learning curve time to feed the next process. For example, process P1, P2, P3, P4, P5. Skill levels A, B, C. Learning time 2 hours, 4 hours, 5 hours. Skill required for the process S equal to A, B, C, D, E. Learning time for C skill operator LT equal to 1, 2, 3, 4, 5 hours. If the operator is C skill to the process, then we have to check the training required. Based on the training required hours, advanced training should be arranged. For example, P3 has required 5 hours of training, so the IE could advise in OB for 4 hours advanced training. Layout. The layout also affecting the garment SMV. For example, if the line layout is the conversional type with bundling system, then bundle handling time should be considered. Or the layout is conveyor system and panel and parts are moving in conveyor, then pickup and dispose of time will be reduced. If the line layout is made for single pieces flow, then there will not be bundle handling time. Based on layout type, the process cycle time and SMV will be changed. The same has to be considered in SMV calculation. Total SMV. Once completed OB, all processes and their SMV have to recheck to confirm all are correct. Check one by one process and ensure that there is no additional or missed in the operation. Once all operations are correct, then check SMV values in every individual operation and check the formula and total SMV. Also cross-check with a similar style whether the details and values are close to that. Pieces per mission. Check and ensure break-even pieces per mission is a key indicator. If they add or reduce the mission, the target also will be changed. For example, the target piece per mission is 25. If a sewing section adds one mission, relevantly 25 pieces will be added in the target. Pieces per manpower. Check and ensure break-even pieces per manpower is a key indicator. If they add or reduce the mission, the target also will be changed. Planned efficiency. Check and ensure it is above break-even and realistic with section efficiency. If break-even efficiency is higher than section efficiency, subsequently leads to no profit. Line balanced. Check the total workstation required and planned. If some of the operations can be clubbed together, then give a clear note on OB. A well-balanced OB can help to avoid the bottleneck process during the production run. Summary of missions. Cross-check the summary of mission required, process-wise machinery required, and the total mission should be the same. If we combine one operator for two process or one operator for two missions, then it has to be updated accordingly. Summary of manpower required. Cross-check process by process manpower calculated. Allocation of lesser manpower may lead to a bottleneck process and subsequently become a critical process. Other end, allocation of more manpower cause for operator idle. Smooth flow. Once completed the operation bulletin, check the take it time and SMV weightage. There should not be more deviation between SMV weightage and take it time. Workmanship divided and manpower allocation should be distributed evenly. Learning curve, assembly line versus modular system. Percentage of target achieved day 1, day 2, day 3, day 4, day 5, day 6, day 7 and day 8. Conclusion. Operation bulletin should be considered 360 degrees analyzed details. Considering maximum and relevant parameters assist to prepare an accurate operation bulletin. The same can be testified and proven. This kind of operation bulletin and its details always will be acceptable. Thank you for watching. For more sessions like this, do like and subscribe to my channel. Please comment your valuable thoughts and don't forget to press the bell icon to get notified when I post a new presentation. Bye, have a good day.